I always start every lesson with a question, and I put the question up on the board so kids can start getting their thoughts and their ideas, kind of ground them, and where we're going to hope to end up the lesson.
How does a phenomenon-based unit frame the work of science so that we foster and value students' ideas? And what can a teacher do to support student ideas, especially very different student ideas, and ones that may not be exactly where we expected them to head?
What do you say, Morgan?
So let's think. You want everything by
Phenomenon-based science units must be anchored in phenomena that are relevant to students. But they also should leverage a lot of different ideas so that sense-making, the back and forth exchange of ideas, is rich.
My reasoning is mosquitoes carry diseases and so do other bugs. Why is this good evidence? Because insects carry diseases also.
So this is good evidence because insects carry diseases?
Yeah, like...
Or if bats carry Ebola, that's how they got it. And
monkeys did.
So monkeys did what? Monkeys did not carry
Monkeys did carry Ebola, yeah.
And so did bats. Look at, they get it from the fruit. Like,
Oh yeah, bats eat from bananas.
and bats eat fruit.
In a traditional science class, students are used to trying to figure out the right answer. And if they don't know the right answer, they may not share. But students, like adults, learn more when they are given room to come to some of their own conclusions.
So there are some kids in your science room who will tell you they hate science, that they're not good at science. And then you'll give them a lesson, and they can't stop talking about it. They'll stop you in the hall. They'll call you at home. You'll get emails about this particular lesson, this particular question. And you'll say, oh, I thought you didn't like science. And they'll say, oh, I don't like science, but I like this. And so the trick as a science teacher is to make sure every single kid in your classroom understands that they can do science and that there are places they can come into science from so many different angles, that every last one of us is a scientist and every last one of them can do science.
Many species of bats are threatened in Wisconsin, and some are listed as endangered by the federal government. Use what you read yesterday, use what you heard today to generate a list of what's currently threatening bats, okay? You're going to use that list to write a claim. And your claim is going to be, this is what's causing the bat population to decline. But figuring out causality involved complex ideas in ecology, in earth science, in biochemistry, and even in physics. After different experiences with the phenomenon, the students are supported in generating different ideas. The phenomenon and the sense-making promote authentic science work.
Burning of fossil fuels makes a heat trap.
Okay, that was yours.
Fossil fuels
So the burning of fossil fuels.
create a heat trap.
Okay.
Natural predators.
Natural predators.
Natural predators. What are they?
Snakes.
Snakes.
Owls. Raccoons.
Yeah, raccoons. That was a new one, right? This idea contrasts with another group's thinking. So what about wind turbines?
Bats are drawn to them and then their lungs explode if they get too close.
Yeah. Another group's idea focused on humans and deforestation.
And then like deforestation because that's their houses.
And urbanization.
And pesticides.
Students offered various ideas in the BAT unit, and I try to always take a sense-making stance with them. A sense-making stance means that I assume that the student is leveraging their own meaning towards understanding the phenomenon. Instead of focusing on what is wrong with the idea, I try to indicate where their thinking is using some of the tools needed for the understanding.
So what is your theory? What's happening to the little brown bats?
That the big brown bats are eating all the food.
Actually, I was saying that.
What did you say? Well, tell us the rest.
I was saying that the big brown bats were going around and eating up more food than the little brown bats.
So there wasn't enough for the little brown bats. They were out competing them. Yeah? Okay. All right. That's reasonable. We'll see. We're going to look into it. I think when we do our research, we'll find that it's not just one thing.
We consider how even so-called wrong ideas are the stuff of sense-making. Tell me what you got for the threats.
So the threats that we got were that the humans take down trees from the bats so they can hunt for food and stuff like that. And then they lost food supplies from that, and some humans hunt bats, and also
Wait, what?
some humans hunt bats.
What does that mean?
Like they kill them because they think they're dangerous.
Okay. Conservation ecologists and bat specialist Paul White offers invasive species and biota on the bat's wings as the right answer for why white-nose syndrome is a problem for little brown bats. A combination of some of the ideas presented by students, as well as some other factors such as size, influenced the little brown bat's decline. A scientific discourse with a lot of ideas is rich. In the next video, we'll explore how students become part of figuring out the practices to ensure the sense-making is rich.